This is video P4, part 1. Topics covered on today's video will be conditionals and identities, fractional equations, and rational equations including extraneous roots. You can pause the video at any time to make some notes for yourself. All right, let's look at the first topic today, conditionals versus identities. From geometry, you might remember that a conditional is simply a statement, if then. If something happens, then something happens. And so all equations in a way can be thought of as conditionals. For instance, look at these equations that I have right here. First equation says 2 times x minus 1 equals 2x minus 2. Now, what we could say is if x equals 3, for instance, is this equation true? And so we can solve the equation and we can find out what value of x would make that true. So let's go through here and find the solution. Use the distributive property, 2x minus 2 equals 2x minus 2. Now, at this point, you notice the left and the right sides are exactly alike. We could continue combining like terms as much as we wanted, but eventually we're going to get to a statement like this. Let's subtract this 2x from both sides, and we're going to have 0 there, 0 there. Negative 2 equals negative 2. Okay, or then we could add 2 to both sides, and we would get 0 equals 0. No matter where you stop this process, at any of these places I've drawn arrows, these are all true statements. And when you lose your variables and you cannot solve your equation and it is a true statement, then this is called an identity. And what that means is that this equation is true for any value of x. 1 makes it true, 2 makes it true, 3 makes it true, whatever. Now, my second example, 2 parentheses x minus 1, let's work through this one. 2x minus 2 equals 3x minus 12. Let's combine the like terms, and 1x equals, add 12, x equals 10. Now, this one has a solution, so we could call this a conditional, and what that means is that this equation is true on the condition that x is equal to 10. Now let's put it in and check. 10 minus 1 is 9. 2 times 9 is 18. 10 minus 4 is 6. 3 times 6 is 18. 18 equals 18. This is the correct solution. This is true if this condition is met that x is equal to 10. That's the only time this statement is true. Finally, in our third case, look at this one. 2x minus 2 is equal to 2x minus 2 plus 2. So let's work it through. 2x minus 2 equals 2x plus 0. And so 0 equals 2 if we bring the 2x over and we bring the 2. Now this statement right here is not true. That is a false statement. And what that means is that this is false no matter what the value of x. There is never a way this is going to be true. So this one has no solution. All right, in summary on this section then, what we're going to say is that statements, I'm going to slide this down just a little bit, that these equations have one of three possibilities. They are either true for everything, in which case they're called an identity, or they're true for only one value, which is called a conditional. If that condition is met, the statement is true, or they're not true for any solutions. So when you are working with equations in one variable, you will either have one answer, many answers, infinitely many answers, or no answers at all. All right, that's part 1 of today's lesson. Let's move on. Let's review part 2, fractional equations. Fractional equations are exactly what the name suggests, equations that come to you with denominators of numbers. And what we want to do is find the value of x that makes this equation true. Now, the easiest way to do this is to look at the greatest common factor, the least common multiple of these denominators. Or if you want to do it easily, just multiply them together. You get 12. And what we want to do is we want to go through and we multiply 12 times every part of this equation. And it is not childish to write that 12 3 times. It's much better to do that than to miss one and not get it right. Now, 3 will go into 12 4 times, so this piece has now been changed into a 4x. 4 will go into 12 3 times, so this now is a 9x, and this is a 24. And now we'll finish the problem. 13x is equal to 24, and x is equal to 24 over 13. You can write that as a mixed number if you want, but I'm going to leave it. Now, the purpose of this is to take this fractional equation, which has two levels, a numerator and a denominator, and reduce it to one level. I like to say it's like a two-story house, and we're going to take it to a one-story ranch. So that's the purpose of a fractional equation. Now, let's look at a second example, a little more complicated. 3 halves times z plus 5 minus 1/4 times z plus 24 equals 0. Let's distribute first. This is 3 halves z plus 15 halves minus 1/4 z minus 24 fourths, which is 6, equals 0. Now, you see the two stories? Let's look at the denominators. We've got a 2, we've got a 2, we've got a 4, and we've got a 1. So if you multiply each part by 4, you will be able to clear all those denominators. Get a red pen so I can show it a little bit better here. Let's multiply this by 4, this by 4, and again, don't be ashamed to write it every time. It is so helpful to try to get this going. All right, 2 goes into 4 2 times, which means that piece is going to now be 6z. 2 goes into 4 2 times. This part is going to be 30. Watch this sign right here. 4 goes into 4 minus 1z. 24 minus 24 equals 0. And now again, you've taken it from 2 stories to 1. Let's finish it up. 6 minus 1 is 5z. 30 minus 24 is plus 6 equals 0. 5z equals negative 6, and z equals negative 6/5. So a quick review on how to work with a fractional equation. Get rid of the fractions, clear the fractions by multiplying. You can go back and check this if you have time. All right, our final example today, rational equations and extraneous roots. All right, now let's go back to what we just did. Look at these fractional equations. Notice the denominators of all of these problems were numbers. Okay, these were fractional equations, have numbers in the denominator. This is an example of a rational equation. Notice it has a variable in the denominator. Now, I know you know from Algebra 2 that this particular denominator will factor x plus 3, x minus 3. So we're wanting to multiply by, again, the least common multiple of all these things, which is x plus 3 times x minus 3. So let's multiply through x plus 3, x minus 3. Let's multiply here, x plus 3, x minus 3. And let's multiply here, x plus 3, x minus 3. Now what happens, of course, is that this x minus 3 takes out this x minus 3, and you end up with x plus 3 times 1, which is x plus 3. This x plus 3 takes out this x plus 3, and you have left x minus 3 equals, and this whole denominator takes out this whole numerator, and you just have left with a 10. Now let's finish the equation. 2x plus 3 minus 3 is 0 equals 10, x equals 5. Now, with a rational equation, it is possible, you see these denominators, you want to go back to the original equation and make sure that this 5 will not produce a 0 in the denominator. Now, it turns out it does not, so this is a fine solution. Notice x could not have been 3 or negative 3. Those would have given you zeros in the denominator. And you can go back and check this if you want to and make sure that solution is right. Now, this one does not have an extraneous root. Some of the ones in your homework tonight will. So we're just going to put a note here. Check for extraneous roots or extraneous solutions. And the way you know those are extraneous is they will give a 0 in the denominator. That's not good. Can't do that. So if your solution produces a 0 in any part of your denominator, it's extraneous and you would throw it out. Okay, that's enough for this lesson. Part 2 of section 4 will be tomorrow night. Thanks for listening.